talking about quantum computation, which sounds like sci-fi to me, something that I can see on the movies, and that's it. But my reflection about it is that we're talking about open technologies, we're talking about the technologies of tomorrow, because when we talk about artificial intelligence or quantum computation, whether you go on holidays, if you go on holidays for 2 weeks, it seems that you're missing out on it and you have to catch up. So instead of waiting to get all the wave of information, instead of waiting for Google and the like to talk to you about it, pay attention to this talk by Andrea Vesco, Chief Researcher in Cybersecurity and Lex Foundation, and Nicola Tuveri, a researcher at the Tampere University, moderated by Mr. Fumero, Antonio Fumero. Yes, thank you. Just a second, please. Just a second.
No sé si...
I don't know if you remember Helikin. There he is. Has lost his bag, his backpack. He just got it back. He just found it.
Okay. So, from one European Union funded project that is closing to another one that is initiating, that is executing, that is QBIP. We have Andrea from Lex Foundation and Nicola from Tampere University joining us for talking about not exactly quantum computing, but to talk about the quantum secure future for all using post-quantum cryptography. That is the topic of our project that Cibervoluntarios is joining a consortium with these guys. That is a consortium led by Links Foundation with a lot of interesting partners like Red Hat, for instance, Links Foundation, Tampere University, Cibervoluntarios, CSIC in Spain, that is a research institution, very well known in Spain, and some other universities. And as we were talking before, one of these big elephants in the room is the AI, and the other one is quantum computing. I mean, when you are talking about quantum computing, you are talking about something that is complex in itself as a concept to understand to regular people. So in our case, in Cibervoluntarios and this event, we are pretty interested in the relationship between people, persons, and technology. So one of the things we need to do here is to make our audience understand what are we talking about when we are talking about quantum computing, and what does quantum computing really mean for all of us in our daily lives. I mean, for sure, there are a lot of complex concepts and ideas behind the quantum physics that are supporting quantum computing advance in these years. But we are more interested in is how is quantum computing or a post-quantum scenario modifying our daily life? How are we browsing the internet? How are citizens using the services we have available online? And how is this impacting all this stuff? So, first of all, you can for sure who is Nicola, okay, who is Andrea, and after that introduction, we can go to the topic directly. How is quantum computing affecting our daily life basis?
Okay. So Hola, soy Nicola, and that's all the Spanish that I can speak.
Great.
Hello, I'm Nicola, and that's all the Spanish I know.
Researcher at Tampere University, and I'm more specializing on what I like to call cryptographic engineering. And I also have the honor to serve as a member of the OpenSSL Technical Committee, which leads the technical governance of the OpenSSL project, which is widely adopted all over the software ecosystem. And I will let Andrea answer to who is Andrea, and then we can go back to the quantum computing question.
Hello, everyone. Andrea Vesco. I lead the Cybersecurity Group at the Links Foundation. Links is essentially a private research center in the city of Torino, in Italy. And I'm also the coordinator of these QBIP projects. And there I lead a group of, let's say, 12 wonderful researchers. Half of them are mathematicians, the other guys are computer scientists, and so we use these two different expertise to tackle the cybersecurity problem in general. In particular, QBIP deal with what is called the post-quantum cryptography. I'm absolutely not an expert on quantum computer, and no one in QBIP is expert in quantum computer, but what we know that from one side, for sure, this new capability, new computational capability will be the next advance in technology, and this kind of technology will help several different researchers around the world to make a quantum leap in several research areas. So many advances will arise in the future, also thanks to this new computational capacity. The other side of the coin, or the other side of the moon, is that if you don't use it with ethics, one of the action or capability of quantum computer is to break and crack the cryptography that we all use today to secure our communication. I mean, your connection to your home banking, your communication with your family that are today secure with what we call the classical cryptography. The quantum computer will be able to break, and we know that since the 90s, that kind of computer will be able to completely crack this cryptography that we use today. And here, QBIP. We essentially are tackling one of the two actions required to solve this problem. The first one comes from the cryptographers that around the world are designing this new crypto. And the other side are the engineers that have to understand how to make the migration of existing protocols and systems to use the new cryptography that is resistant to the quantum computer. So
Quantum secure cryptography.
That's the, let's say, the field in which QBIP live, essentially. So we are taking a serious step. We are one of the first two projects funded by the European Commission to understand how to essentially counteract this problem well before the quantum computer will arise, because today the capacity of the quantum computer are, let's say, not enough to break any of the cryptography that we are using. But in the near future, this will arise.
And if I can add to what Andrea said.
Yeah, for sure.
Like, one more reason to, one way to explain to the people why this is relevant now and not after we get a powerful enough quantum computer is that there are two very important things that affect our lives every day, and without even realizing that we are using it every day. So the first thing is every one of us every day in most of his digital communication is relying on the traditional cryptography to have security. But all of this security comes, is endangered by the advent in the future of a quantum computer in the case that an actor, a government agency, or nefarious
any attacker.
anyone could be recording now conversations that are secure because are protected by the cryptography that we use today, but that will stop being secure the moment they get access to a quantum computer. So if we want to, it's called harvest now, decrypt later. So the idea is that all the conversations that we're having now, all the secrets that we are exchanging with our home banking or our private communications with anyone could be endangered right now because they are recorded now and then can be decrypted later, and that could break the cryptography. And the other important factor that is pushing us to do the transition well ahead of time right now is that transitioning all our digital ecosystem to using the new alternatives takes a long time, both because of technological reasons. It actually takes time to migrate existing systems to new solutions, and also because we need to build the same level of trust that we have to the current cryptographic solutions that we are using for the new alternatives that are being proposed that can run in our traditional computers but are also resistant to a quantum computer.
But the point is that this transition process is not trivial. I mean, we have to take into account a lot of different variety of factors affecting this transition process depending on the context. I mean, we have to transition to this quantum secure scenario using hybrid strategies, using traditional cryptography and post-quantum cryptography combined. But we have to take into account that this process is to be applied in different scenarios. I mean, the enterprise in the civil society. I mean, you've been talking about the regular, the application that citizens are using on a regular basis. I mean, I'm accessing my bank account or my bank app in the mobile phone every day, almost every day. And you are stating that all these transactions are affected by this post-quantum scenarios. So what are the strategies we are considering for designing this transition process? What are the attributes of this transition process we have to take into account to be successful? Because at the end of the day, what we are talking about is that all the communications and networks and all the communications transactions we're using on a daily basis, all of us in our company, in our daily basis, are affected by this quantum future that is coming. Other thing is that the consideration, we will talk fortunately afterwards on the forecasting on that, but what are these attributes of this transition process? What are going to be taken into account for being successful in this transition process?
I think I will let Andrea answer, but this is the main focus of the Qubit project. So the end result of the Qubit project is coming out with a playbook that can guide different actors into the transition with concrete steps and suggestions on how to address very specific use cases, because each different use case has different requirements, and those affect how this transition can be deployed. But Andrea can give more.
Yeah, let's say from the project perspective, we are going to address the transition at different levels. So we start from different building blocks that then are put together in real system. And the three real systems that we are considering in the project are, the first one is digital manufacturing, so essentially how to protect the connected manufacturing of the future. Of course, maybe I think the most widely spread application all over the world, that is internet browsing. And the third one is how to protect the network of telco operators that are the agent that provide access to the network to every one of us. The point about the complexity is, there are several points of complexity. One of the most important is that the new crypto that is now developed, essentially now developed, is not mature enough like the one that we are using today. So the crypto that we are using today essentially has been designed 30, 40 years ago. So a lot of, let's say, real world experiment has been done. This is not true for PQC, and this is why one of the most important principle of the transition is called cryptographic agility. In essence, we have to redesign or implement the existing protocols to use new crypto, but we need to be ready to change if someone in the world, some cryptographer or other scientist found a bug in this new crypto. And we cannot just remake everything. And so agility means I want to plug new implementation tomorrow, if I have to, without rewriting everything. That is what we are doing now. So the principle of cryptographic agility is, let's say, the most important in general in this field.
And one final question. I was wondering, how is the open source principle role in this crypto agility for this scenario of quantum secure future for all? I mean, is open source principles, or are open source principles having a key role in this crypto agility for all the different agents involved in this transition?
Absolutely. So actually, we are using open source solutions in basically all the layers of the QBIP project. So personally, with Tampere University, we are involved in the migration of OpenSSL, which is a cryptographic library, NSS, which is another cryptographic library maintained by Mozilla and Red Hat, and Mozilla Firefox, which is an internet browser. And they are all open source components. And the fact that we can do this transition and have very transparent discussion about how to do it and what are the trade-offs and what are the alternatives and how are we choosing among the different ways of doing this transition is possible just because we are leveraging open source solutions and we are contributing back to the open source ecosystem, whatever are the solutions that we find or recommend for the transition. And that applies to other layers as well. So one of the partners, for example, you mentioned is Red Hat. So most of these experimentations, also involving the end users, thanks to Cibervoluntarios, will happen using Fedora, which is open source Linux distribution that is freely accessible. And that gives us the option to see what are the requirements and how to proceed to the transition at the operating system level. So it's not enough to just change one library or a set of libraries. Making this change in one building block affects as many ramifications across the operating system. And again, the fact that these full suite of tools are available in the open source ecosystem is what empowered us to come up with a proposal that was realistic, because doing this with a completely closed source ecosystem wouldn't have been possible, I think, not at this multi-layered approach that we proposed in QBIP.
Yeah, all the results will be packed in 10 different key exploitable results, so everything will be published on the GitHub of the project and will be available for any other cryptographer or cybersecurity expert in the world to apply them in their own system.
Great. We have time enough for 1-2 questions from the audience. 1 or 2 questions from the audience. One of them is there.
Thank you very much. The achievement of quantum supremacy feels a lot like developing a nuclear bomb. It feels, at least based on the publications. It feels that there is a race. It's more or less transparent. My question to you, is it possible to imagine a scenario that somebody achieves the quantum supremacy who is not on the radar? And do you think, is it possible, based on, like the configuration of scientists, scientific communities, and so on, because it's a big thing. It feels like hard to hide, but not impossible to hide. So first of all, is it possible to hide a development of project of this side? And the second, what if it happens? You mentioned a playbook. What if we face a sudden, quantum supremacy by one of the actors? What do we do?
So you're very right with the comparison with development of nuclear weapons. And actually, in all the language talking about the advent of a quantum computer, this parallel with like the nuclear winter and apocalyptic scenarios is constantly reused. The answer to the question is complicated in the sense that if you put 50 researchers in the same room and ask these questions, you probably will get 50 different answers on how likely this is or not, what are the chances. Personally, I believe that it's very, very improbable that a cryptographically relevant quantum computer is developed without people being aware of it. In the sense that, at least to our current knowledge of what are even just the physical resources needed to power and maintain operational a quantum computer that is powerful enough to actually break cryptography, are so big that, first of all, it requires a very big and with means organization, and also it's so big that it's very difficult for anyone else in the space not to notice that this massive amount of power is being used for something that we don't know what it is. Of course, it's not totally impossible, but personally, I believe it's not that likely to happen tomorrow. And there is a constant joke about the fact that whenever we ask when we will have this quantum computer, or like the powerful enough quantum computer, it's always, well, 10 years in the future, but it has been 10 years in the future for the past 30 years. That's why it's important to think about the fact that even though maybe it will take still a long time to have this quantum computer, the transition needs to happen way before that happens. And it's so slow. There is so much latency in the deployment of these new systems that we are now already kind of late. So we want to accelerate the transition now so that whenever that quantum supremacy was to happen, no matter who is the actor that achieves it, we are well ready, and that even an attacker that is harvesting now information to be decrypted later doesn't have years and years and years of backlog of secrets that they could decrypt suddenly and compromise our identities, our secrecy, our past communications.
Final question from the audience. Okay, so thank you very much, firstly to the audience, to be here till the end. Thank you very much for joining the event. Don't forget that tomorrow we'll be back. Okay, so thank you, Nicola, Andrea. My pleasure to have you here.
And thank you for the organizations to inviting us.